Okay, guys, in this video, we are going to review spherical coordinates. And in this example, we are integrating, so we got a triple integral, and we are integrating z cubed multiplied by square root x squared plus y squared plus z squared. And we are integrating this over half of a sphere. And the sphere, obviously, it has radius of 5 because we've got x squared plus y squared plus z squared equals 25. So 25 is 5 squared. But we do have a sphere that lies above the xy plane. So it's not the whole sphere, but just part of a sphere. So let's see if we can, first of all, set up the limits of using spherical coordinates. So how do we do that? So number one, we are going to fix phi and theta. Phi is the angle with the z-axis and theta is the angle with the x-axis. So what will happen is that if we fix the angles, then your rho is going to change, which is the distance from the origin to the point on the sphere. And because we are integrating over the whole solid, it's not just the surface, but it's everything inside it. So it's going to start at 0 all the way to the radius of the sphere, which is 5. Okay, so that means that when I start setting up the coordinates, this is going to be d rho, d phi, d theta. Okay, so for rho, as I said, that's going to be 0 to 5. Okay, so the next thing is thinking about how about the angle phi. So the angle phi is the angle with the z-axis. So if you are on the very top over here, your angle with the z-axis is going to be 0, right? But as you keep moving over here all the way down, right? So your movement goes this way. That will change. So the angle on the top will be 0 because again, this is the angle with the z-axis. And then when you reach over here, that's when it's going to be 90 degrees with the z-axis. So pi over 2. So that will make this phi change from 0 to pi over 2. Now, this was the whole sphere. You would go all the way down to pi. Okay, but you're not going to go all the way back up. You're only going down because you can't have points have different phi and theta and resulting in the same point. So you will have to kind of like double count some points if you go all the way back. So for phi, you never go to 2 pi. You stop at pi if it's the whole sphere. If it's top half, then you'll stop at pi over 2. Now, what about theta? So theta is responsible for going around the sphere. So if you fix r and phi, then theta is the angle with the x-axis. So this will really be just going around. And because it doesn't say anything about the first octant, so sometimes they say that, then both angles will be from 0 to pi over 2. But here, it's all the way around. So the theta would go from 0 to 2 pi. Okay, so what else do we need to know about the spherical coordinates? So number one, we need to know that every time we switch to spherical coordinates, we're going to wind up with an extra factor, rho squared sine phi. This will always be there regardless of what you have to integrate. So for example, if I wanted to find the volume of this hemisphere, I integrate 1. But I still have to include this factor rho squared sine phi because that's responsible for switching from rectangular to spherical coordinates. Now, what else? Okay, so we do integrate z cubed here. What is that? So z in spherical coordinates is rho cosine phi. And that's just the connection between them. So z cubed would become rho cube cosine cube phi. Now, what about that square root? So in spherical coordinates, you need to know that x squared plus y squared plus z squared always becomes rho squared. And that comes just from the first trigonometric identity, using it a couple of times, so you can show that. And here we got the square root of that. So square root of this will just become rho. So that's an extra rho here to integrate. Okay. So now that we put it all together, let's see if we can split it apart and compute the integral. This is actually not hard once you set it up, because these integrals are all splittable. You can split it into 3 different ones. So because all the limits are numbers, and the integrand is just a product of something that has rho and something that has only phi. There is no theta in there, so regarding theta, we'll just be integrating 1. And then for phi, you are integrating cosine cube sine. And for rho, you are integrating, if we collect them all, looks like I will get rho to the 6th power. So that goes from 0 to 5. Okay, so the hardest integral here would be the inside one. The other ones are very easy. So this first one will just be 2 pi. This last one will become rho to the 7 over 7, and then we substitute 0, 5. Now, how do we handle this kind of integral? So this is trigonometric integrals with odd powers, and usually this is handled by substitution. So I will use substitution u equals cosine phi. If I do that, then du becomes negative sine phi d phi. So this part right here, that is almost du except for the negative. So that's negative du. And then this part right here becomes u cubed. So integral of u cubed is going to be u to the 4th over 4, but I'm just going to substitute cosine back in there and also include the negative because this was a negative right here. And so then I will substitute 0 pi over 2. Okay, so with that said, let's see what's the final answer. So this will be 2 pi. Let's first substitute pi over 2. So you should know that cosine of pi over 2 is 0. So that'll give me 0. Then I'm going to substitute 0. Now, when you substitute 0 into cosine, that's 1. And then that's going to be negative 1/4 because there was a negative over here. Right, so we got that done. Now over here, that will just be 5 to the power 7 divided by 7. Okay, so this looks like that's 2 pi multiplied by 1/4 multiplied by 5 to the 7 over 7. You could simplify 2 pi over 4 and make it pi over 2, but other than that, that's it.